Okay, this is section 2.6, and we're looking today at operations of and compositions of functions. Okay, so let's first talk about operations on functions. Of course, that means addition, subtraction, multiplication, division. So, when the important part of this is generally just a notation, so you understand what it's asking you to do. So if we're given the functions f of x and g of x, then the notation this book is using, if it has an f plus a g, that says, well, you're going to take f of x plus g of x. If it has an f minus g, that's an f of x minus g of x. If just the f and g are written next to each other, of course, that means I'm going to take f of x times g of x. And if it's f divided by g, of course I'll take f of x divided by g of x. And of course the one stipulation here, we know that g of x cannot be equal to 0, because that of course would be undefined. And then another side note here, because often you're asked about finding domain, and of course the domain of the operations include all the real numbers in the intersections of the domains of f and g. So basically, the best way to do that, when we get to an example like that, is to even graph out the domains of f, domain of g, and the ones that overlap, the intersection of those two domains is the domain of that operation. Okay, so let's run through some examples for this. And again, this generally is not real difficult. Maybe the simplification is the hardest part of this. So example 1, let's let f of x be defined as x squared plus 1, and g of x be defined as 3x plus 5. And so A, let's find f plus g. Oh, not of x, I mean of 1. Of 1, not x. We'll put a actual real number into that's a 1. Right, and so as you know from the notation, right, that says, well, let's find f of 1 plus g of 1. That's all that means. So, this is pretty easy. We just mentally, f of 1 says put 1 into the f. So we would have, one would be 2, yeah, 2. And then to find g of 1, we put 1 into g. And so the answer is just 10. If we want to do B, f minus g, and this time this time do the x. So just f minus g of x. All right, so we don't have an actual value to put in. Bless you. So, well, the notation wise that says take f of x minus g of x. And the only tricky thing here is to make sure you subtract all of g. So f, of course, was defined as x squared plus 1. Now, if I write it just like this, what problems does this imply? What problem do I have with that?
What does that mean? Where you scribbled?
Oh, that's a 1. That's just a 1. So I do the whiteout on that.
On the yellow paper.
Yeah, I don't have any.
If we could get yellow.
I don't have any yellow out.
Yellow white out.
You can, but I don't have any. You can get the yellow out, but I don't have any. So I'll be with white out. So what's wrong with how I wrote it here? Not that it's not simplified, but look, I'm subtracting only the 3x, right? In fact, make sure you put parentheses around this. You want to subtract all of g. This says subtract all of g, not just the first term. So, and then when I simplify this, right, my first step is to distribute the negative through. Okay, so now what can I combine? Well, not a lot. But I can combine what? The minus 4? That's all I can do. So not a lot. Okay, so let's see. We need a C yet. So what if I had just fg of x? And of course that says, well, let's take f of x times g of x. Okay, so that says, yeah, I need to take x squared plus 1 times 3x plus 5. And that I can simplify. How do I simplify that? Yeah, I have two binomials, so look, I can take and pull that out, right? So the first will be x squared times 3x, 3x cubed, and the outside,
5x squared,
inside,
3x,
plus 5 at last. And then what like terms can I combine? Well, in fact, none of them, right? And so I'm just left with that. Now, the other example I want to do is one that deals with domain. And you know, generally speaking, of all the things of this, maybe domain's probably the more confusing. So we look at domain. So this is problem 2. Now problem 2, I'm going to redefine my functions. I'm going to let f of x equal 8x minus 9 and g of x be equal to the square root of 2x minus 1. And so I want to find the domain of f minus 9 of x. So remember, what we said to do on this was find out the intersection of the domains. Right? Find out where the domains intersect, and that's your domain of that operation. So let's find the domains of each one and kind of graph those out. What's the domain of function f? What's the domain of f? Yeah, f is this 8x minus 9. It's everything, right? There's no restrictions, there's no division, no radicals. So it would go just, I'm going to graph out from negative infinity to infinity. It's everything, right? All these values. And then underneath I'm going to write the domain of g. So the domain of G. Now what's this going to be?
Can't be a half.
Is that it? So remember, for a square root, I need what's underneath the radical. I need the 2x minus 1 to be what? Greater than or equal to 0, right? I need it to be 0 or above. Whatever's underneath the radical. So this is an easy inequality to solve, a linear inequality. So I'm going to add 1 to both sides. 2x is greater than or equal to 1. Then divide by 2. So x is greater than or equal to 1/2. So that says on my graph, right, let's say here's a half. Well, in fact, we put what, a closed dot and everything here. Now, all I have to do now, my domain is where the two graphs, what values they have in common, right? What values they intersect. So the domain of f minus g would be what? Yeah, so I've got all these values, they come together here to here, right? So it would be in interval notation, how we probably would write this. Would be from square bracket, right, a half to okay. All right, so let's do one more like that. This time I want to do the domain of the domain of f divided by g of x. Okay, so I really have the same graphs as above, right? So domain of f is still all real numbers. So f still goes from negative infinity to infinity. And g still goes, didn't change that at all, from a half to infinity. G would have a closed dot, right? But there's one more stipulation on this.
0, so you wouldn't have a greater than equals to sign when you solve that. You solve greater
Well, if I'm just looking at G would stay the same, right? But when I look at this division of functions, I know that g of x cannot equal 0, right? So when I write my answer, the domain of f divided by g, what would it be? Open bracket, right? I cannot include the half because a half makes g of x 0. So the only very difference on this one is that you can't include the half from dividing. Now the other type of question I want to cover before we go on to composition, because you have some of these in your assignment, is they give you some graphs. So let's do, and I probably just want to use an example of my book on this one. 3, finding the values from a graph. And we're just kind of run through these values out of let me get my problem in my book here. Although this does have the answers, we'll just go through how to do this, because you have something like this on the computer, I think. And we'll just work through 31 here. You guys can see that okay. Okay, so the thing is, you just, in this case, you just read off these function values. So, on A says, this says take f of 2 plus g of 2. Okay, so define f of 2, right? That says, well, when x is 2, what's the function value? So when x is 2, the function value looks like it is 4, right? That's 4 plus g of 2, when x is 2, g is negative 2. So 4 plus negative 2 would be the 2. Right, that's all you got to do on these. On this one, right, it's f of 1. That's 1. Minus g of 1. G of 1 is negative 3. Right, so 1 minus negative 3 is 4. And you can see how that works. Here, D, I'm going to skip C. D, f of 1, right, is 1 divided by g of 1, which says negative 3. Just did that once, negative 1/3. So it's very simple, nothing tricky about it. Just find the values off the functions, right, and just do the operation. That's all you got to do. Now the ones that are a little more tricky are with composition, and we'll talk about composition next. Okay, so oh wait, I guess we'll do the difference quotient first, then we'll do the composition. So I guess that's in this section. So this is, what am I ready for? Letter, Roman numeral 2 is all? Yeah, 2. So 2 is going to be the difference quotient. And I need to zoom back out.
Oh my goodness, what are you doing? Yes, dude.
A little blurry.
A little bit. I didn't even realize your pen was actually black. What color is it? Blue?
It's blue. It's supposed to be
It
blue.
looked like it was lime green.
Alright, the difference quotient. So, this is kind of, the reason this is in this section, it's really an application formula. So it's a function formula. And really the biggest reason why we cover this is because it has some applications largely in calculus. But the formula given is, so the difference quotient, the formula is f of x plus h. I think this book uses an h. It could be sometimes maybe other things in other books. Minus f of x divided by h. So this just says what to do, right? Find f of x plus h, then subtract from it f of x, and take all that divided by h. So let me run through a couple examples of what this will look like. So let's start. So to start with, you have to be given a function to apply this. You can't just apply without a function. So this first one here, I'm given f of x equals 5x minus 6. And of course, the direction I want to find the difference quotient. So all we do is exactly what this says, right? We do exactly what this says. So the first thing to find is f of x plus h. How do I find that? What do I put into the x in the function? Right? This says take x plus h and put into the x in the function. F of x plus h equals, you don't have to do this extra step, I'm going to do it just to make sure you guys see that, 5 times x plus h, replace the x with what's between the parentheses, minus 6. So I'm going to rewrite this again. So it's 5 times x plus h minus 6. That's this. What do I subtract from that? Minus f of x. Put that in parentheses. I'm going to subtract all of it. What's f of x? 5x minus 6. Divide everything by h. Now, when you do the difference quotient, a lot of things should simplify. There's lots that you should be able to simplify. And so now the next thing is just now you want to simplify. So let's see, I can distribute in this first step, right? I can take the 5 through 5x plus 5h minus 6, distribute here, minus 5x plus 6 divided by h. And then things should cancel. It almost always is the case that lots of things will cancel out. So see, the 5x cancels with out, and then the 6's, minus 6 and plus 6 cancel out. So I'm left with 5h over h. So what can cancel here? H divided by h is 1, and the answer is 5. So it's just 5. Alright, let's do one that's a little more challenging because, so that's a linear one, pretty simple. I want to do a quadratic one yet. I don't want to go any higher than a quadratic. But let's try this. So 2, I want to, the function, this is going to be, let's see, we're given f of x equals x squared plus 2x. You want to find the difference quotient. Okay, so same thing, right? I'm going to first find, so I guess remind ourselves, the difference quotient is f of x plus h minus f of x over h. This is what I'm trying to find. Right there, right? So to find f of x plus h, what goes into the x's? Well, in each x, I put in x plus h. So it's going to be x plus h squared plus 2 times x plus h minus f of x, which is x squared plus 2x divided by h. So this one, the more difficult part is the simplification, right? You got more things to square out, and so just distributing through. So we got to remember how to square things out. So let's see, x plus h squared would be, well, the formula says I square x squared. Then I have 2xh plus h squared, right? If you have to, you know, just fool it together of x plus h times x plus h, right? And that's what that is. Distribute here, minus 2x, not minus, plus 2x plus 2h, then distribute here, minus x squared minus 2x. Now once again, lots of things should cancel out. So what cancels out here?
X squared, x squared.
Alright, so we get rid of the x squares. That's gone. This is gone. This is gone. 2x is gone. So now what am I left with? Well, I have 2xh plus h squared plus 2h divided by h.
We can get rid of the h's.
Yeah, in fact, every term has an h in it, so I'm going to factor it. I prefer you factor it out so you make sure because it has to be in every term to cancel it. So h times 2x plus h plus 2 over h. And again, h divided by h is 1. I'm left with 2x plus h plus 2, and that's it. So that one's a little more challenging, a little more involved in that. Okay, the last thing on this lesson is with the composition of functions. And so let's start that. So this was actually ready for number 3. Okay, so first off, the notation is probably the same you've been somewhat familiar with. And that is, this book will use that it uses an open circle, so f composed of g of x, kind of the standard notation for that. Now, of course, that means then that f of g of x. Right, and we often will call the g of x, in this case, this is the inside function, and the f becomes the outside. And we can find values with this, so we can find expressions with this. So this first one, let's let f of x equal 2x minus 9, and g of x equal 4 over x minus 1. And let's say that I wanted to find f composed of g of 2. So it may help to rewrite this, that what this means is I'm trying to find f of g of 2. But in fact, g of 2 actually has what value? So g of 2 is what? 4 over 2 minus 1, which would be, so this is actually equal to 4. So now this says this find f of 4. So f of 4 would be 2 times 4 minus 1, which would be 7. That's it. So find the value of the inside and then substitute in to find the value of the outside. Right? And keep in mind that composition is not commutative, that different ways often gives different results. In other words, g composed of f of 2 may or may not be 7. Most likely it's not. So g of f of 2. Well, what's f of 2 equal to? F of 2 would be 3. Yeah, so 2 times 2 is 4 minus 1. Let's make this is 3. So this says find g of 3, right? Be 4 over 3 minus 1. So g of 3 is 2. So yes, they're not necessarily the same. Now, you have some examples on the assignment that will give you the function not as an expression but as a table. Let's do an example like that next.
No.
So, number 2. So we're giving, the function is given as a table. So we define f as this function (1, 4, 2, 3). We're given this as a table. So we don't have no idea if they're actually what the rule is or the expression is, but that doesn't matter. Okay, so that's how, here how we define G this way. We define G. And now I'm going to use that to find some of these compositions. I want to find G composed of F of 1 to start with. We're going to work this essentially the same way as we did with the expression. I want to find G composed of F of 1. So I have to find my inside first. What is F of 1? F of 1 was when X is 1, F this is 4. So now what's G of 4?
5.
G of 4 is 5. The answer is 5, just like that. What about F composed of G of 4? We'll work this the same way. What is G of 4? G of 4 is 5. What's F of 5? Yeah, it's not there, right? In fact, it's not defined. We say it's undefined, which is an okay answer. So you don't have to have every value that's defined. You could have an undefined one. Let's do one more today, and that is F composed of F of 3. So a composition of a function on itself. Find F of 3.
So F of 1.
F of 3 is 1.
1 is 4.
So the answer is 4.
I like those. Those are easy.
Good.